Hey, how is it going? Today I'll talk a little bit about how to use heaps or priority queues in Python. I originally learned about data structures and algorithms in C++, and it was kind of weird using them in Python, so hope this helps. If you want to read the documentation yourself, you can go to this website. It's on, if you go to, right, type Python heapq, it's the first thing that pops up. This is the on Python documentation and all the functions that you use and what they do are basically here. Before I start, I also want to note that these functions were added in one of the latest versions of Python. It might not mean anything right now, but I'll explain how these change the usage. So I guess we can get started. So why do we even use a heap? How does it work? What's the main idea? I guess to think of a heap, it's usually implemented as an array in C, C++, and what it mainly does, what you need to know about it is it can either be a min heap or a max heap, and based on either it's a min heap or max heap, it literally gives you um, of one access to the top element. And here by top, I mean either the min or max based on, again, which type you're using. And if you want to pop the top element or add a new element to it, it gives you of log n complexity to either remove the top element and put whatever the new top is there, or add a new element and again figure out whatever the new top is there. Um, so again, this is to add or remove the element and new element and keep the invariant that the top element is either the min or max. So yeah, and why would we even need it? Well, in a lot of cases, you really care about what the highest element or what the minimum element is. For example, in LeetCode 2, there are some questions like, I don't know, there's a question such as the kth largest element, or there's a question like, or when you're coding something, you sometimes want to see the largest price in a dynamic data stream or whatever. And you don't really want to necessarily sort everything because when you're sorting everything, what it basically does is you get an ordering for everything. So if you have one, two, three, four, five, and maybe they're in some scattered order like five, one, three, two, and let's say zero, four, maybe it's zero to five. And when you sort it, sorting gives you 0, 1, 2, 3, 4, 5. But when you have a max or min heap, to simplify your understanding of this, basically, if you have a max heap, it's going to have 5 as the top element, and everything else is going to be here in some undefined order. So you don't know if they're ordered or not. And they're not. So you can't really say anything about what the second largest element is. Similarly, for a min heap, you get 0, and you don't really know anything about um, the second smallest or the third smallest. So this is a big idea. Now, why can this help again? Because in a lot of questions, you don't really care about the total ordering of everything. Like for example, if you want the max heap, you want 5, but you don't necessarily care how 4 compares to 3 or 1 compares to 0. You don't care. You just want to know whatever the largest is. And this also saves you some of the complexity of sorting. So, um, yeah, so again, let's go into how this works in Python. First of all, you need to define a list as such. I'm just going to call it heap, but it could be L, it could be list one, it could be my list, doesn't matter. But I'll call it heap to make it clear that we're going to be using this as a heap. And to use the priority queues or heaps in Python, you need to be importing heapq. So this is what you need. And heapq inside has all these functions defined. So it has heapify, heap push, heap pop, heap push pop, and heap replace. Now, usually when you want to use a heap, you have some elements inside. So let's say 400, 5, 1, 3, 17. I'm just making some numbers up. And let's say I want to use this as a min heap. So by default in Python, when you are using heapq, heaps are min heaps. So if I want to turn this into a heap, I do heapq.heapify, which is this function over here, which says transform list x into a min heap in place in linear time. So heapq heapify, and I put in the heap variable. I pass in the heap variable. Now the interesting thing here is that it's done in linear time. I believe there are two ways of doing it. One of them is bubble up, the other one is bubble down. One of them, which is used here, is able to basically turn this into a heap in linear time, which is also pretty cool. Again, you don't have to have the n log n complexity of turning this into a heap originally. So yeah, this turns it into a min heap, and let's see what we have. So like I said, 1 is here, but when you look at the other numbers, you see 3 and 5 also good, but you see we have 100 here, and it appears before 4 and 17. So like I said, you don't really know the total ordering, but you know whatever the first element you have, this is going to be the smallest element. By default, min heap, like I said, in this version. And another function, and also by the way, in Python, if you want to access the top element, you could just do heap.0, which is basically how you access the first element of a list. Again, the first element is the smallest, so this will be the top of the heap, which is the smallest element. Okay, so probably the second function you want to use with, and by the way, this notation, heapq heapify, you're basically calling a function inside this heapq module, so that's why you have this dot notation. It shouldn't really be confusing. I guess like this is how, if you're not used to it, like maybe in C you've seen this, a lot of functions take in, it's not really object oriented. When you're calling a function, you pass in whatever you're going to modify, so it's similar to that. But again, the second function you probably are interested in is to add something to the heap. So for example, let's say we want to add -1. To do that, you do heapq heap push. And you'll soon see that all of these functions start with the heap word. So it's like heap push, it's going to be heap something else next. But when you want to add something to the specific heap, you add the heap here. So whichever heap you want to add to, then you pass the value you want to add. So I'll add -1. And also as a note, if you are starting with a non-empty heap, so if this list is not empty, you should call heapify to make sure that the starting state is defined and you have the way the library expects it. But if you had, for example, a empty heap here, you could just call this without heapify because there's nothing in it. And when you call heap push, it's going to be doing the work behind the scenes to make sure that this is a valid min heap. Um, but yeah, you only need to call heapify if your original heap, the list you're starting with is non-empty. So let's just like keep with that original heap we have, this list. I'm going to add -1 to it, and let's see what our heap looks like. And let's see what the top of the heap is. So I should probably print the heap here too, just for consistency. So this is what we originally had, these two lines, and now we have the new heap with the addition of -1. So that's how you add an element. Just heap q, heap push something. What if you want to pop something? So that's basically heap pop. And you again only pass the heap because you expect something. So when you do heap q heap pop, it returns the value. So you can do val equals heap q heap pop. And what you could do is print value and print the value. And also, again, let's print the heap again here. So we can do that. We just here over here, we just we just pop the value from the heap, which was -1 because we just removed the top element, and we have the remaining heap now. So after -1 was removed, we have the rest of the heap, And again, the top of the heap is 1 now. Because why? We had -1. We had originally this heap was this. It was turned into this one. When we added -1, it became the smallest number. So it was over here. And when we popped -1, 1 came as the smallest number. 1 became the smallest number again. Good. So sometimes these are the basic functions that you're going to use, but sometimes you want to combine two actions. And what I mean by combining two actions is sometimes you want to push something and pop something. And if you combine these two, it actually does both of them at the same time, so it's a little bit more optimized. And what I mean by that is if you call these separately, it's going to be 2 log n. And log n is the number of elements in the heap. So you're basically having the same cost twice. But if you there's a function that combines both of these actions in the heapq module, and that is heapq.heap, again starting with heap, push, and then pop. Now, this is the ordering. So it pushes something first, and then it pops afterwards. And as an example, let's say we push and pop something from our heap. And I'll give you two examples here because I think this is interesting. So let's say we push and pop, and whatever we're going to pop, we're going to get as a value here. So let's say val is equal to that. And whatever we're pushing, we need to pass in here. So let's say we're pushing 200. So let's see what this looks like. I want to print the value. I want to print the state of the heap and top of the heap. So if we call, if we run everything again, let's see. So we had 1 here, and we just pushed 200 and then pop something. So we were in this state, this highlighted state. We just pushed 200 and we removed the top. So as you can see, value is 1 now. This top of the, maybe I should print here something to make sure that the division like it's distinct, or like it's easier to see. So we're here now. The top of the was 1. We pushed something and we popped something. We first pushed, then popped. Whatever we got by popping is called val, which is value here. So we got 1 back, and we also added 200. So now the top of the heap is 3, by the way, because we got rid of the 1 as well. Now the interesting behavior here is that, let's say we had this output. I'll put it over here. Oh, it doesn't let me. Let me see. Okay, yeah. So we had this output, and we were pushing 200. But what happens if I instead decided to push -100? And now, interestingly, we just pushed at -100. But wait a minute, we also got it back. So how does this work? The way it works is that, like I said before, it calls push first and then pop. And the idea is that if whatever you push becomes the top element of the heap, which is -100, which, yeah, is the smallest number here, it's actually popped immediately. So this might trip you up a little bit, but this is basically how it works. Now, if you instead wanted to do something more like, okay, I don't wanna push first, I wanna pop first, and then I want to get whatever that value is, and then do something, or if that's what you want to do. So in that case, there's actually this function called heap replace, this one, which is basically the last function that you need to know. This is it pops and returns the smallest element from the heap, and then pushes the new item. So this is basically doing the same thing as push pop, but it's in a way popping first and then pushing. And it's called heap replace. So let's see what this looks like. So let's forget about these lines of code for now, and let's see, we have this heap. So we have this heap 135. These values, we know 1 is the smallest. Again, we don't know anything about the ordering of the rest of them. And here what we want to do is we're basically going to, let's say I want to make sure that 1 is removed and I put something else here. But I don't really want, like, I want 1 to be removed. Let's say if I put negative 100 here, I don't want negative 100 to be removed. I want 1 gone. And the way you do that is you call heapq heap replace again with the heap and whatever value you want to add. So if I want to add 100, negative 100 for example, the way this is going to work is what we expect here is it's going to first pop 1, so value is going to be 1, and then it's going to add negative 100, so the new top of the heap, the smallest value is going to be negative 100. So let's see if that's true. Let's see if that's true. And that is true. So it popped 1, it got 1, and it added negative 100. So it's basically doing the same thing as heap push pop, this function that we covered just a moment ago, but it does it in reverse order. So you're guaranteed to get the top elements. And whatever you add, like you're guaranteed to get the old top element, and whatever you just pushed, so negative 100, you're guaranteed to keep it in there, even though it's the new smallest number. Yeah. So this is how a heap in Python works. And like I said, by default, it's a min heap. So what do we do if we want a max heap? Well, that's a good question, and that's where it gets a little interesting. And the reason why it gets a little interesting is that until Python 3.14, if you wanted to have a max heap, you basically had to make every single number negative before you put them in the heap. What do I mean by that? So what you needed to do was that you basically went through all the elements in the heap and just did something like this, or maybe create a new list, but um, you basically made everything negative, and you basically needed a heap like this. And why is that? Well, I haven't called heapify yet, but let's see what it looks like when we call heapify with this negative everything negative heap. And let's print it again. So interestingly, we have negative 100, negative 4, negative 17. Again, these are not ordered. So the smallest one is the top one, and then negative 17 is smaller than negative 4, but negative 4 comes before. So these are not ordered again. We just know that the first element is the smallest one. But how does this help us? Why do we make everything negative? Well, it helps us because when you make numbers negative, you basically get the largest number as the smallest one. So in a way, your 100, which was the largest number here, when you make everything negative, it became the smallest number, just by virtue of changing the sign. But how does this help us? Like, still, it's very complicated. What do I even do? Well, yeah, it becomes a little more difficult to reason about, but it's basically the same thing. You just need to be a little more careful about how you do the operations. So, if you want to reason about the numbers, what you need to do is, for example, if you want to add a new number in the heap, and if you want to keep it as a let's say as a max heap, and let's say we have value to add is 15. So I want to add 15 to this max heap. Well, what you got to do then is heap push with heap, but now you need to add value to add negative. You want to add whatever you're going to add negative. So this unfortunately is a little more confusing, but if you get used to it, it's not going to be too different. So look, we just added negative 15. And let's say we want to add 200, we add negative 200, so now we have the top as negative 200. Okay, we have negative 200, but the second mistake a lot of people make here is that when you want to get the top element, you got to get the negative of it. So if you're accessing heap's top element, and this is a max heap, you got to print negative heap 0. So the top is actually 200. So you got to make these negative conversions along the way. The same thing goes for heap push, heap pop, heap replace. They all work the same. The only difference is that if you're going to do heap push with heap, whatever value you're going to put, you need to put the negative of it, so that it's everything here is negative and it serves as a max heap. And all the functions, heap push, heap pop, heap replace, everything works as before. You're just making it act like a max heap by making every number negative. So you just gotta be careful about what you put in and what you expect to get out when you call heap pop, or when you call heap replace, or when you call heap push and pop. What you pass in and what you get out. Now, I the first few minutes in the video, I mentioned that these were added in Python 3.14. You can use these as well, by the way. So these, what they do is, people realized how annoying it is to keep making every single number negative and then adding negative numbers and then turning whatever you get out of it, making basically what you get out of it times negative, or expecting the negative of what you get. So it was confusing, and people said, okay, let's actually add a default max heap too. And all these functions, heapify max, heap push max, heap pop max, basically the same function names with underscore max at the end. They do this conversion for you, so you don't have to deal with the negative numbers. The downside is that since Python 3.14 is still relatively new, LeetCode or a lot of interview platforms don't have it. So if you look at this, pre-release is 3.15, and Gemini says latest table is 3.14. So this is the latest table, but I think a lot of platforms, HackerRank, LeetCode, still don't have the latest version. So you might not be able to use it. So let's see. Let's see if this website has it. And we can basically just call heapq dot heapify max with this heap and print heap. And let's see if this is actually running all recent enough Python. And as you can see, it says doesn't have attribute heapify max. It says there's a heapify underscore max. I believe this is an internal function that you're not really supposed to use. These are the real functions that you're supposed to use. We can check what version this is running. I think the command, yes, print sys version. So the way we get whatever version this platform is running is by importing sys and sys.version. So we see that it's running 3.12, which is common for a lot of websites, so it doesn't have it. But let's go back to the error we got. So it was saying no attribute heapify max. Did you mean underscore heapify max? Like I said, this is an internal function that you're not really supposed to use, and when you call it, it actually worked. But if you, I don't even think they talk about this in the documentation. Yes. So they're not really guaranteed. It's not really something you should be using. And in fact, it doesn't even have heap push max. So actually, let me try it like this. Yeah, so heap push max doesn't even work. There's heap pop max, but not really heap push max. So um, again, long story short, if you're running not the latest version of Python, you really only have these in your toolbox. So you have to pass negative numbers in the list and expect negative numbers out of it if you're using a max heap. If you have a min heap, it's just easy work. You just call these. If you have a later version of Python which has these functions properly and they work, meaning like you have, if you have this version of Python is going to work, then also you can just use these instead of passing negative numbers in there. So hope this helps. I think this is basically what you need to know to use heaps. This is really useful in LeetCode in interview questions. And yeah, hope this helps.